do math 2. And in math 2, connect the iPad. And we're looking at a new unit in MVP 4. And it's useful to think about going from different forms, okay? And so if we've got this factored form, x minus 1, x plus 3, we can FOIL it to get to our standard form. So it'd be x squared, and then we've got 3x, then minus x minus 3. So our factored form would be x squared plus 2x minus 3. And let's go ahead and complete the square. And so that looks like we would just do plus 1 and minus 1. So we'd have x squared plus 2x plus 1 minus 3. So it's x plus 1 quantity squared minus 4. Okay, so let's see if what we can figure out if we have all three forms. Okay, so then we should say, all right, our y-intercept is going to be minus 3. Okay, our so we have this, then the minus 1 and minus 4 should be our vertex. And our zeros, our x-intercepts should be at 1 and minus 3. Okay, so let's see if that's true. Okay, so we look at this and we say, well, when x is 1, y is 0. Okay. And when x is minus 3, 1, 2, 3, x is 0. Now, that doesn't look right. And so 1, and then, so it's actually 4 apart, right? Minus 1, minus 2, minus 3. Okay. Plus 1, minus 2, minus 3. Okay, and now you say, well, where's that line of symmetry? So the line of symmetry is here. And so we can use this to get the vertex, but another way to get it is to say, what is the value when I'm at minus 1? So if we put in a minus 1, so we say, okay, my vertex is going to be at minus 1. So minus 1, minus 1, minus 1 plus 3. So I get minus 2 plus 2 equals minus 4. And so that's another way to get it, is that you can, so you say, oh, there's my intercepts, but we know that our vertex is exactly half. So if I put in a minus, I also get that from this as well. Okay, so you get your x-intercepts. Okay, from here you get your y-intercept if you multiply it out. And if you put it into, if you complete the square, you can get your vertex. Now, what I would say is, as you get good at this, you can find your x-intercepts, and then say halfway in between is going to be the x value of my vertex, and then just substitute it in there to get it. So let's look at another one and see if we can do the same thing. Okay, and so we look at this and we say, I know what the intercepts are. So it's going to be 2. If I put a 2 in there, I'll get a 0. Or if I put a 6 in there, I'll get a 0. 2, 4, 6. Okay. And so what's our line of symmetry? So our line of symmetry is going to be 4. Line of symmetry is 4. And so if we put in a 4, so we say 2 times 4 minus 2 times 4 minus 6. Put that in and say, well, that equals 2 times 2 times minus 2. And that looks like minus 8 to me. And so it looks like minus 8. So we say, okay, well, 1, 2, 3, 4, 5, 6, 7, 8, all the way down here, I guess. Okay, so now so our x-intercepts are 2 and 6, and our vertex is at 4, minus 8, and x equals 4. What's our y-intercept? Okay, and so when will we get 0? And remember that if we multiply this out, so we have 2 times x squared and minus 6x and minus 2x is minus 8x, okay, and then plus 12. Okay, so what happens when x is 0? So when x is 0, we'll get 2 times 12, or 24. So we go all the way up there to 24. Okay, so what, however, would happen if you wanted to complete the square? So let's just go ahead and complete the square for this one. And so we'd say 2, and we've got x squared minus 8x plus 12. And we look in that and say, well, what do we really? And so you could try and get fancy, right? So let's see if we can get fancy with this. X squared minus 8x. And that would just be 16, right? So we need to add 16 to it. So we need an extra 4. Okay. So you say, oh, well, outside here, I need 2 times 4. And I'll have to subtract 2 times 4. Okay, so they say, okay, let's try that. And so that allows us to bring the 4 inside. So we get 2x squared minus 8x plus 16 minus 8. Okay, so we have 2 times x minus 4 squared minus 8. And so that gives us also our vertex 4 and minus 8. Okay. So that, I think, is something that is worth practicing. So know that I've ever done it quite this way as well. Okay, so let's say that we have factored form. So we have x minus 1, x plus 3. Let's take the easy one. Okay, so we have x minus 1, x plus 3. So find the line of symmetry. So we find the, so we say it's 1 and minus 3. Okay, so the line of symmetry is halfway. So the line of symmetry is halfway between. So it's at minus 1. And then we put minus 1 in to the factored form, and that will be the y value of the vertex. Okay, the x-intercepts, of course, we just solve for 0. The easiest way to find the x-intercept is, I think, to multiply it out. So FOIL it out and find the vertical stretch. I think the factored form has it. So, right, so in the other one, we had 2 times x minus 2, x minus 6. So there was the stretch. So let's look at the next one. Choose any 2 linear functions. Okay, so not quadratic functions. Okay. All right, so let's say that you have y equals 2x plus 1. So you say, okay, well, the f of x equals 2x plus 1. So m, so I guess I mean the slope, right? So we're going to say, okay, so that equals 2 times x plus a half, right? So that would be equivalent. So f of x is 2 times x plus a half. And let's say that we had another one. We start out with y equals 5x minus 3. Okay, so you say, okay, so f of x equals 5 times x minus 3/5. Okay, and if we were going to graph it, you know, so we're sort of over here. 2x plus 1. So intercepts there, and then we go up by 2, so our slope is 2. That's the red one. And then the green one, 5x minus 3, so we go 1, 2, 3, so we're down here, and then our slope is 5, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so let's do the product of the two functions. So p of x equals, let's say, f of x times g of x. All right, so so we look at this and say, well, I'm not sure where this is going, but let's give it a try. So we'll take x and we'll have 2x plus 1. So you have a feeling that they want to put it into that other shape, right? So not one I've ever done before. 2x plus a half times 5x getting a quadratic, right? So we say, okay, let's give this a try. So we have 2 times 5. So we say, okay, we'll put those together. And then we've got this x plus a half, x minus 3/5. Okay, so there's our factored form of a quadratic. Okay, it's got a vertical stretch of 10, which we learned about. And so the roots, so what are the zeros for it? So the x-intercepts are going to be minus a half and 3/5. And in between, so the line of symmetry, okay, is going to be a little bit harder to figure out, but we can do it, right? So we just have to, I guess we take the midpoint of these, right? So let's say minus a half. So minus a half plus 3/5. So it's still going to be on 0, right? Divided by 2. So minus 5/10 plus 6/10. Okay, so 1/10 divided by 2 is a 20th. Okay, is that halfway in between? All right, so minus a half, 0, 1/20th, 3/5. Okay, so how far apart are they? Okay, you say, well, altogether they are 5/10 and 6/10. So they're 11/10 apart. 11/10 apart. So half of that is, so you say, okay, that's 22/20. So half of that is 11/20. So 11/20 apart. And so that looks right. So you say, okay, so I've got this line of symmetry at 1/20. So describe the relationship of x and the linear function. Yeah, all right, who knows? All right. Okay, so it's an interesting thing. I'll have to look it up. I've never even thought about this before. So main thing though is just try and work on the first step there. All right. So